Hello, this is a quick primer into Catalyst, which is section 12.7 of your textbook. Chapter 12 is the kinetics section of your textbook, aka the rates of reaction. Now, rates of reaction are very important things to understand because if a reaction is happening too fast or too slow, that can greatly affect whether or not we want to do that reaction in the first place. A reaction that happens too fast may cause explosions. A reaction that happens too slowly may be impractical, unpractical for what we want to get from the reaction. So anything that can increase or decrease the rate, anything that can control the rate of reaction is very useful to us chemically speaking. And catalysts are an example of this. Now, we often use catalysts in order to speed up a reaction. Catalysts help to create an alternate reaction pathway for two reactants. Examples of catalysts in nature include enzymes, proteins in the body that bond to substrates, and this helps to cause a chemical reaction to happen, or catalytic converters in cars. So cars produce a lot of very poisonous, very toxic gases due to combustion of hydrocarbons, so burning fuel. Those poisonous gases will come into contact with a catalyst called a catalytic converter, and this, in combination with oxygen in air, will react and form less dangerous products. So although cars produce lots of carbon dioxide, actually that is a much more preferable product to carbon monoxide, which is incredibly toxic to human beings. So catalysts are pretty important in controlling the rates of reaction. One thing it must be said is that when we measure the rate of a reaction, we measure the rate of reaction way before it actually reaches equilibrium. Because once a reaction reaches equilibrium, the backwards reaction starts to affect the overall rate of the forward reaction. I mean, it makes sense, right? You want to measure the speed in which products are formed from reactants. Well, because systems do eventually reach equilibrium, then it will affect the forward reaction if we allow the system to get to equilibrium. So we don't measure the rate of reaction at a point where the reaction has already started to go backwards to an appreciable effect. So in fact, the most important point on a rate of reaction graph is what we call the initial rate, the rate as soon as two reactants, are added together. Now, we're going to focus more on catalysts and the concepts behind them. First, we're going to look at how we can see their effect on a Boltzmann distribution graph and an activation enthalpy, the enthalpy graph. Then we're going to have a look at the mechanisms in which catalysts work. Okay?